There are two platforms associated with movement. Let us suppose the movement of the platform on the left is given by V1 and the one on the right as V2. Let us first consider the movement of the left platform. The spring force resisting movement is Fk1. Hence, we can write an equation of movement where F in minus Fk1 will be equals to 0. For the second platform, the forces acting on the mass M would be Fk1 due to the spring, Fb1 due to the damper B1, and Fk2 due to the spring K2. Hence, the equation of motion would be Fk1 minus Fb1 minus Fk2 is equals to 0. We next consider the mechanical element, the mechanical flow, the electrical flow, and the electrical elements. It is quite easy to list down all the mechanical elements, which is F in, K1, M, B1, and K2. We next associate the mechanical flow to the element. For F in, the mechanical flow involved is V1. For the spring, it will be the case of V1 minus V2, and for M, it will be V2. For the damper B1, V2, and as well as the spring K2, V2. The next step of incorporating the analogical electrical flow to the mechanical flow is very straightforward. Finally, we complete the table by including the equivalent electrical element. In the case of force, the equivalent is input voltage. For K, the spring, capacitor, a mass, inductor, a damper is a resistor, and again another spring is another capacitor. The next step is to incorporate a sketch of the electrical circuit. In the case of I1, only one element is associated with it. Hence, we can draw a voltage source with a current I1 flowing through. We next identify the current I2 and the elements, an inductor, resistor R1, and the capacitor C2 that's associated with it. Hence, beyond the node, we can sketch an inductor, resistor R1, and a capacitor C2 associated with the current flow of I2. Finally, for I1 minus I2, a capacitor C1 is associated with it. Hence, from the same node, we have a current I1 minus I2 flowing with a capacitor C1. From the sketch, we can create the final circuit, which looks as such, where the current I1 flows through the first mesh and I2 through the second mesh. It is interesting to note that there are two meshes flowing through, and there are two equations for the movement mechanically.